Hi, everybody. This is going to be Go Math, Chapter 12, Lesson 5, the first two pages. So, as we continue on our chapter on measurement, we're going to get into a slightly different area here on line plots. So, starting on page 487, our essential question is how can you make and interpret line plots with fractional data? Almost said fictional. All right, so let's go to the unlock the problem. This is where we're going to really see what a line plot is. And we've seen them before. Maybe we just need to brush up on the vocabulary. So the data here, the data show the lengths of the buttons in Jen's collection. For an art project, she wants to know how many buttons are longer than 1/4 inch. You can use a line plot to solve the problem. A line plot is a graph that shows the frequency of data along a number line. So as we scroll down here, we see her information. These are all of the button lengths. And then our directions here. Make a line plot to show the data. Step 1, order the data from least to greatest length and complete the tally table. All right, so this is going to draw from lots of skills that we have been building. I'm going to take a quick snip of this page. I'm going to get all the problems on it, including the information in that purple box. All right. So first things first, we got to put them all in order and make sure that we remember how to put fractions in order. So in my first video of the day, I haven't taken my pen out yet. All right, so using the information in this box, I think because I'm zoomed in a little bit, my point size is too thick, much better. All right, so we're going to take the smallest fraction here, which is going to be all of the 1/4. So it would look like this, 1/4, 1/4, and 1/4. Now I tend to cross them off as I use them here because I want to make sure I end up with the proper number of fractions at the end, that I didn't miss one, didn't double up on one, that sort of thing. I have 3/4 left and 4/4 and 4/4. So the next one here would be a 3/4. And then the final two, and you must list them all, would be 4/4. So at the end of this, we should have 1, 2, 3, 4, 5, 6 fractions. So I'm going to go check my work. 1, 2, 3, 4, 5, 6. Okay, so we're good on that. Step 2 says, label the fraction lengths on the number line below from the least value of the data to the greatest. Okay, oops. I'm actually going to come over here to the button collection first and say we have 3 tally marks, 1, 2, 3 buttons that are 1/4 in length, 1 button that's 3/4, and 2 buttons that are 4/4. Okay, so nope, still not in that one. Here we go. So now I'm going to label this number line, and they have very nicely labeled this number line for you already. I will start with one thing, as I wish that they had listed all the way back to 0, and I'm going to show you what I'm talking about in just a second. But they had extended this to include a 0. It's a little confusing when you start with 1 that there's no distance in there yet, so I'm going to add my 0 and extend that number line just a little bit. So I'm going to come back up here to see how many times did 1/4 appear in my data. How many buttons were 1/4 in length? And that's going to happen 3 times. So I'm going to put 3 X's. 1, 2, and 3. And now I know that I had 0 in the 2/4, so I'm just going to leave that alone. I don't need to put anything there. I had 1 button that was 3/4 in length, and I had 2 buttons that were 2/4 in length. Oh, we need a title down here too. So if we are looking at, uh, maybe we just call this Jen's Buttons or something along those lines. So we'll call this something like that. So blank buttons are longer than 1/4. So now we actually have where we need to look at the number line with our X's, our data points, and answer a specific question. So it's not asking how many buttons I have in total, it's asking how many buttons are longer than 1/4, which means that I am not going to count, and I changed my color, it did not change. That none of these over here are going to count. I'm going to count everything going this way. So 1, 2, and 3. So I have 3 buttons are longer than 1/4. All right, so math talk here. Explain how you labeled the number line on the number line in step 2. Um, all right, we labeled it. There you go. How many buttons are in Jen's collection? This is a total number, so you would count all of your X's. So we have 1, 2, 3, 4, 5, 6. So she has 6 total. What is the difference? Question 2. What is the difference? This is a key word for subtraction in length between the longest button and the shortest button. So my longest button is 4/4 and my shortest button is 1/4. So the difference in length is 3/4. Kind of a tricky way for them to sneak in some subtracting fractions there on this problem. But line plots are important. They provide lots of data and lots of different ways to ask questions. So you may feel like you need to come back to this example more than once. All right, time to close that window and look at our book again. Looks like we're pretty good to move on here. Let's see what the next example is. So I'm going to take a quick snapshot of this example and we're going to get started. Okay, example 2. Some of the students in Miss Lee's class walk to school. The data show the distances these students walk. What distance do most students walk? So we're going to be looking for the number that occurs most often. And we're going to go through the same process here. Order the data from least to greatest distance and complete the tally table. And this is the tally table over here. And I'm going to take a look at my fractions. Now I have lots of 1/2s. 1/2, 1/2, 1/4, 3/4, 1/4, 1/2, 1/2. And you probably can already see what number is happening, what fraction is happening more often. That's fine. Keep that in the back of your head for a minute. I'm going to focus right now on these 1/4 here and here. They are my smallest fraction. 1/4 of a mile is like 1 lap around our track. 1/4, 1/4. Now I have lots of 1/2s, so I need to list every single one. So I need 1, 2, 3, 4 of them. Here's 2, 3, and 4. So now I can cross them off. And my largest fraction here is 3/4. I'm going to erase this off just so that I can see my originals again. And I have 1, 2, 3, 4, 5, 6, 7 fractions. And here I should have 7 too. 1, 2, 3, 4, 5, 6, and 7. All right. Down over here, distance in miles. On my 1/4 of a mile, I have 2. On my 1/2 a mile, I have 4. And my 3/4 of a mile, I have 1. Now, just a quick note here. Remember that 1/2 is also equal to 2/4. So some equivalent fractions in here. They are assuming that you know this and have remembered that it would go 1/4 of a mile, 1/2 of a mile, 3/4 of a mile, and then if we needed it, 1 whole mile. But just in case you didn't, remember 1/2 is 2/4, so we have 1/4, 2/4, and 3/4. Alrighty. Let's scroll up a little bit. So now we get to label our data. Now, again, I'm going to tell you that I wish this number line went from 0 to 1. It does not. I'm going to fill in where we're going to write in the most, and then I'm going to fill in the rest of it too, because I just don't like it like this. I'm also going to tell you that 1/2 is 2/4 as well, and this is 3/4. So what I wish they had done in this number line was complete this to 4/4 and started it at 0. That's just me. As long as it makes sense to you, let's continue. But I feel like this gives you a little better picture of it. All right, so I get 2 x's here at 1/4. I get 4 at 1/2. And I get 1 at 3/4. So, and we need, I guess this is a good title here, but it's too long. Let's call this miles walked. Try not to get into my graph. It should be capital O. Okay, so most students walk, I'm sure you probably guessed it already, 1/2 mile. This is by far our winner of how many students walk, what the distance they walk. So oh my goodness, most students walk 1/2 mile. See how easy it is to get distracted. There we go. All right. So hopefully this makes sense to you. Definitely go back and listen to it. Both of these examples are pretty good for explaining line plot. Okay, let's see our questions down here. How many more students walk 1/2 mile than 1/4 of a mile? And of course, I just erased that. So I know we had 4 students who walked 1/2 mile. Well, I'm going to have to snip and sketch this again. And I want to take a quick peek at our data and 2. So it's going to be 4 students who walked 1/2 mile and 2 students who walked 1/4 of a mile. So the problem is going to end up being not subtracting fractions, but actual numbers. So I know that 4 students walked 1/2 mile, and I know 2 students walked 1/4 mile, or 1/4 of a mile. So it's going to be 4 students minus 2 students to find out how many more, which is another keyword for subtraction. 2 students walk 1/2 a mile, then 1/4. 2 more students walk 1/2 a mile, then 1/4 of a mile to school. All right, what is the difference between the longest distance and the shortest distance that students walk? Well, that's pretty easy. We're going to take our longest distance, which was 3/4 of a mile. Of course, it's not on here anymore. To our shortest distance walked, which is 1/4 of a mile. And we're just going to do a quick subtraction. Of course, your denominator does not change, and your subtraction is 3 minus 1, which is 2. So the difference in the distance is our students who walk 1/4 of a mile to our students who walk 3/4 of a mile is 2/4 of a mile, or 1/2 a mile. All right. So number 5 says, what if a new student joins Miss Lee's class who walks 3/4 mile to school? How would the line plot change? So, of course, I've already erased this, but I want you to think about this. In the original line plot that should be on your paper, where would you put the X for the new student who walks 3/4 of a mile? Now, once you place that X, does it change the highest amount, like the mark with most X's? Does that now make 3/4 of a mile have more X's than 1/2 a mile? I don't believe it does. So your line plot changes because you add another student's X, but it doesn't change how the most common, like the most frequent distance to walk, which was half a mile. So I'm going to leave that with you. You guys kind of work on that a little bit and go ahead and write your explanation in. All right, this finishes the first 2 pages of Chapter 12, Lesson 5. I'm going to stop this video and I will start a new one on the next 2 pages, guys. I hope this helps you and I hope to see you soon. Bye-bye.